Meteor Impact.
There we go. So Nacho Codoñer of the MeteorJS core team. And let's see what you have for us.
Okay. Yeah, thank you very much. Okay, so I think, yeah, I'm showing everything that I need. Yeah, okay. So yeah, hello everyone. Hello Meteor community. In this presentation, what I want to do is to look back at what has been done in the last semester around the Meteor bundler, what is already available for you to try, and what is going to come really soon. Let me first present myself. Yeah, this is Nacho Codoñer. I am a developer enthusiastic about Meteor. I am based on Valencia, Spain. And you can find me with the handler Nacho Codoñer in the social platforms. So I also want to talk a little bit about my Meteor journey because yes, I have worked with Meteor for most of my career with 10 years already of experience. The major time of my career has been focusing on products-oriented solution using always Meteor, so that in 2016, I was working with Pathable. Pathable was a top company that fully embraced Meteor everywhere and even hosted Meteor Impact conferences at the really beginning. I was there from the initial first commit of the product until its sadly termination. So that happened in 2023. And in 2023, I decided that I wanted to have a shift on my career in terms of the focus, because I wanted just to focus on the tools, because without products, without the tools, stable tools, you cannot have products, right? So since I love working with Meteor for really long time, I wanted to contribute to its modernization. So even before joining to the Meteor core team, I was exploring how modern tools could be integrated in some way, some easy way if it is possible, into Meteor projects. But those days, and this is what happened to 2023 to 2024, I was not touching the core at all. I was just understanding SWC, Webpack, Rspack, and even capacitor.js, and how those could be integrated in Meteor projects. Then in 2024, I joined the Meteor team to help into the final push towards Meteor 3 official version. We released that with all the benefits on that Meteor 3 release, which is that we can use the latest node architecture and we gain stability, security, and the opportunity to grow in the future. So this was the key for the improvements that were going to happen next. So after a period of stabilization and performance fixes that I remember we take care at the beginning, we have been able to actually start delivering new features. Among those, the experiments that I was doing that year. So now we are in 2025 and we are working on a much needed improvements to the Meteor bundler. Okay, so about the Meteor bundler, I think there is a clear motivation on anyone in the Meteor community that the Meteor bundler was one of the key pieces that needed to be overhauled somehow. And this is something, at least myself, I have felt strongly over the years, but I think everyone, right? So there are key motivations here. The development experience, I think this has been degraded over time. And this has been mainly because the Meteor tool couldn't keep up with the modern advancements, like using fine Rspack, using optimized CLI behaviors, or even integrating dead servers with the latest techniques on hot module reloaded strategies. So this is one of the key motivations. There is another one that is the bundle size, and this is also attached on what modern bundlers can do nowadays. For instance, with tree shaking, this has been some long requested feature, right? So there is this problem with Meteor applications that you had a limit on the size that you could deliver to your Meteor users. So this is another motivation. Another one is the modern setups. As the JavaScript ecosystem is evolving, they are requiring or forcing the bundlers to behave in different ways. But Meteor couldn't catch up into that. So this has been really hard for Meteor projects to evolve technically. And I think this leads me to the last motivations I want to talk about, is that the necessity to use specialized tools in the Meteor core. Why? Because maybe on the past, when many eyes and hands, because Meteor was really popular, we could have even our own bundler, because Meteor originally tried to handle everything by itself and tried to pose some standards for the bundler. But this is not anymore. And by integrating modern tools into the Meteor bundler, we shift maintenance to these external communities, and we can benefit from improvements instantly. So Meteor can remain being the tool where we focus to provide features to build your products quickly with all the benefits that Meteor already has. Okay, so for that, I think we needed to switch a little bit the way we were delivering improvements in Meteor. At least this is what I have tried to think whenever we are working into the bundler. And is that I want to have like a modern first mindset. And this is always start with modern solutions, then handle any regressions if needed, if those are ever needed. And this is a question we need to repeat ourselves to match, because if it is not a standard, maybe we can just left it. And the model is that, okay, we need for sure understand those motivations that we had, and we need to automate the detection of those metrics that will help us to understand if we're improving or not. So this is, for instance, in Meteor 3.2, we added Meteor profile as our way to identify that, of course, the development experience in Meteor was not the greatest at all. And also the bundle size, because the Meteor profile has also the mechanism to detect that. Then think and focus only on modern tools, proven popular tools out there that the wide JavaScript community is using, and try to embrace them. This is an example of SWC in the case of Transpiler or Rspack. Then we validate the results. This is a quick iteration. Okay, we have integrated something. Let's run measurements to confirm if we are fulfilling those standards we want to meet. And then we open a period of beta to try to handle regressions and fix issues. If those issues are easy to solve, okay, we can proceed with it. We fix them. Or we can provide some workarounds where it's possible, or we just put it in a flag or behind a configuration. If there is something really complex to accomplish, maybe it's something that we cannot benefit as a Meteor community, right? So we can maybe drop the support of it and always try to make it opt-in at least. Because the community out there is not using many of the Meteor specific things, and they are making products and a lot of money, right? So maybe we can just skip that, right? So by following this approach, we avoid to re-implement everything ourselves. Implementing things from scratch, expand our scope, requires heavy maintenance, dedicated experts, not only now, also in the future, people that can stay with us, and also can reduce motivation. So I think this kind of mindset could keep everyone engaged, because integrations are usually really easier to handle than implementing everything. So you can have a sense of progress and have quick results about what you are achieving. So let me talk a little bit about the Meteor bundler, but in a high-level representation, because Meteor Core is much more than what you can see in this diagram. But I wanted to focus and stress here for any Meteor user to understand what we have changed, where were the problems that we were having, and specific parts that we have changed by others in the last releases. So first of all, any Meteor project consists in project files. We have several kind of files. We have application files with your server and client entry points. So we have package code. This package code is the one that is using the Meteor core for the Atmosphere packages and the third-party packages from the community. And then, of course, as we are a node environment, we also allow the possibility to use NPM node modules. Then the first component that we have in development mode is the watcher. The watcher is that mechanism, that component that listens for our files, for changes, and trigger quick recompilation so you can have a quick feeling on your development. So this has been built in the Meteor core using a lot of dependencies, because this is an implementation really mature over the years. But we were using, for instance, Path Watcher, Biscode. Also, we were using Node Native Watcher, and also some custom strategies, all in the same way to provide the cross operative system experience we needed for the Watcher, and also to support things that working within volumes and network. Although this has been stable for years, there has been long-standing issues. Like the one most notable, I think, has been that any Linux user was having like a delay of 5 seconds per file on the first reaction, all the time happening whenever you run the application for the first time. So this is crazy. And this is an opportunity to improve, of course. Then we have the transpiler. The transpiler is the process that happens on the application code and the packages code, and in some node modules, you can even force the transpiler to happen. And basically, this process consists into get your code and the syntax that you are using. Probably you are using modern ES syntax, that this is evolving over the years. And the purpose of the transpiler is to get this code and translate something that can be compatible cross browsers. So for this, Meteor has relied on Babel for a really long time. And this has been a stable tool for the JavaScript ecosystem in general. And this is good because even Meteor, those days, were using Babel to even implement their own standards on the syntax, like the nested imports, right? But this is something Meteor is specific. But with Babel those days, they were specialists making this kind of specific behaviors for it. Also, Ray5 is like a tool that allow those syntaxes to happen. However, in this modern era, Babel, even though it is mature enough and it's great to use it, you need to think that at the end, Babel is running on the top of Node, and Node is single core and is not efficient in terms of file processing. So this is one of the limitations for your development experience. Also, Babel has been in the Meteor core from the really beginning, and the setup has become complex. And there is a lot of patch configuration for making, there is a lot of use of proposals for really years ago. And my experience, at least, and the experience that we have got in the Meteor core team is that any update that we try to do that is really risky and can leave your Meteor tool to just break. So yeah, this is tricky. Then we have the bundler. This is a big bag name. Of course, a bundler corresponding many subcomponents. But I wanted to highlight here is that after the transpiler has to translate the files to something that any browser can understand, there is the turn of the bundler or the linker that basically gets those files and link them into one file with a structure of module that is imposed by the Rspack package, and then also applies for production, for instance, the minification process. This minification process is to make your bundle with better size and be more performant for production purposes, of course. So after that, we generate like the final build or artifacts that are going to be uploaded to your production environment. And here we are producing operative system architecture, which is the server bundle, specifically on the native environment that you are running, ARM or whatever it is. Then we have the architecture for the web, where we produce two, depending if the browser is modern or legacy, and also for Cordova. But what is the problem in this bundler component? The problem is, again, there is the minifier, for instance, for production is really slow in comparison with modern tools. And also in the terms of what Meteor does specifically to construct the final builds, there are unneeded architecture compilation that happen in development mode. So in development mode, you don't need at all to hit possibly the web legacy or even Cordova. So there are opportunities here to even improve that process. So yeah, now talking about the modern bundle optimizations. When we have understood with that diagram what the components prone to improvements are, we were about to optimize them. To improve the experience for all Meteor users, we focused first on optimizing the Meteor bundler, even before considering to include here like a modern external tool like Rspack or another thing. We wanted here to understand the basics of the core. I didn't have experience, for instance, so I wanted to understand step by step and try to optimize where we see that could be benefit for everyone. This diagram shows in general what things we changed. And yes, this is our way to understand the limits of the Meteor bundler itself before going forward. So how to enable these optimizations? Starting in Meteor 3.3, you can enable these optimizations by enabling within the Meteor config the modern true configuration. This is happening by default with all new applications that you create with the Meteor create click command. For existing applications, you can just put modern true, and as here there is backwards compatibility ensured, you can expect to get gains and not get any breaking behaviors. If by some reason you get some breaking behaviors, you can always opt out of specific migrations. But if you run into this situation, which is unlikely nowadays, I believe, please report us so that we can improve those areas. So let's talk a little bit about the components and what were the improvements that we did there. For the watcher. For the watcher, you remember that we were using many libraries to control everything and to ensure everything was reacting the watcher. So what we have done here basically is just to use one library that is called Parcel Watcher that nowadays unifies the native watching mechanism across all operative systems with stability and also a clear maintenance schedule. This has fixed the Linux issue of 5 seconds delay, so this has been a great improvement for all those that are developing in Linux. But this has also improved the speed according to the profiles. A little bit, not was the major part, but it was more efficient. Then the transpiler. The transpiler was replaced by SWC. SWC is a Rust-based transpiler with concurrent processing. It is nowadays the most mature alternative with Babel because it supports nearly everything Babel does. This change has brought the biggest performance gains in Meteor 3.3. All code, atmosphere packages, and NPM packages are now processed by SWC, resulting in a much faster responses. Again, if SWC cannot handle entire code, it fallbacks to Babel, the previous implementation, so you can keep this enabled and still get some benefits. But if you want to ensure you get the maximum performance, you can always activate the verbose mode in the modern transpiler option within your packaging. With this, you can show each of your file projects, and if it is using SWC or if it fall back to Babel, and the reason why fall back to Babel, like maybe it was using some syntax that is not SWC friendly, is not standard friendly, maybe something Meteor specific. And here you can decide to migrate or not at all. Maybe you can have few cases and you can just live with it if you take advantage of that. But you have this option to make it your code more SWC friendly and to advance into the future as well, as we will see later. Another part is the bundler minifier. So SWC, again, is the tool that we have used here in order to make faster the production builds. Then the bundler architecture. So we optimizes the process to skip generated unnecessary bundles. For instance, if we are just development in modern browser, we don't need the legacy browser at all. If we are focusing on web, we don't need a Cordova build at all. So we have skipped those smartly only on your development mode, so that this sequential time that was added to produce all those final builds are skipped, and you get the best development experience possible, which was one of the original motivations. So yes, the main benefit of Meteor 3.3 has been faster builds. For that, we have measured with example really known by the community, the simple task application. And here we have seen that on average, we have reduced 50% of time for each of the phases of the Meteor run command. You can use the new Meteor profile in order to get this, but basically these phases are like the first time that you run your Meteor run application, the second of subsequent times that you run your app is some cache involved. You get the original time from Meteor 3.2 and what has been improved with the Meteor bundle optimization. And then whenever you change a file code from your client code or the server code, how much time it takes to reload the browser, if it is client, or to restart the server if you have modified the server code. So this is, at the end, 3 times faster review for your development experience. But also in production, 2 times faster builds. But I encourage everyone to activate this mode and take profiles and share your gains in the community. We want to know if this has been affecting positively to your setup. Then after Meteor 3.3, we know that it brought the major improvements in build times for years. With the next version, Meteor 3.4, we wanted to go farther. We wanted to make Meteor a solid choice for modern development. For that, we wanted to cover the other motivations points that I said initially. So beyond speed and development experience, we wanted to focus on modern features, on setup, on making a flexible configuration in your Meteor project in order to also get smaller bundles. So to achieve that, this diagram now depicts what are the changes that we have been produced in Meteor 3.4. Basically, what we have right now is that there is this Rspack bundler that has been delegated the treatment of your application code for the client and for the server and the notch modules. So now this is offloaded to Rspack, and Rspack, Watcher, Transpiler, and the bundler itself. What happens here is that Rspack will produce an intermediate build, the intermediate build for your client application, for the server, for the dynamic import chunks, for the CSS, for your assets, for everything. And then is the turn of the Meteor bundler, optimized as well, to get the intermediate build, get the atmosphere package code, the Meteor core atmosphere packages and third-party packages, link them together, and produce the final builds. So with this, we have at the end this distributable build with all that you can do in Meteor achieved as well. So basically the benefits are that adopting Rspack in your Meteor application means that we get the best of two worlds. We get the best of a modern bundler, like we have tree shaking, code splitting, we have ESM full support, we have advanced plugins tooling, faster rebuilds, HMR. And with Meteor, we get everything that we love, like this reactive API, DTP protocol, subscription methods. We get the built-in Mongo, mini Mongo. We get also the optimistic UI. We get the atmosphere packages, those third-party packages that make developing your products easy, the accounts packages, all these things. And also the multi-platform support, the ability of only implement web to deploy multi-platform in several devices, Android and iOS. So how you can adopt Rspack already? If you want to adopt Rspack already, what you need to do is to update Meteor in an available beta that is currently is the beta 11. We are still in this process to stabilize the approach and to extend the approach to the different setups that people is providing to us. And once you have upgraded to it, you need to add the Rspack package, new core packages to it. This package is coming by default with the new applications created with Meteor create click command. And for existing packages, there are some few requirements that needs to be met for this transition. I'm going to talk a little bit about those requirements. First, you need to create entry points for your applications. So those needs to be described within the Meteor config in packagation. And basically the entry point is where your your application starts the execution. This replaced the Meteor eager mechanism that was working in really long time. And in fact, it's still working if you just not use this definition. But this is not efficient for modern bundlers, and this is the reason why you need to have this. You need to, remove for your application code only the nested imports, because this is something Meteor specific, and if we have delegated the application code to your Meteor application, this cannot be interpreted by Rspack or by SWC, any component of modern ecosystem. So if you really need to use the nested imports, what you can do is to defer them into the atmosphere packages, because there these are compatible. Remember, Meteor 3.3 introduced this verbose mode so that you can identify each of your project files and which one is using nested imports of their application code and adapt them. You can migrate them to use dynamic imports. These are supported. You can use require, or you can just move it into the top to be standardized. There is also some reserved context in the Rspack integration. There are some folders that are going to be now occupied by this integration. by default is build and build async build chunks within public and private folders. This is to store the intermediate files and be able to the Meteor bundler to detect changes on them and to proceed with the final build compilation. If you want to customize those build contexts, you can do that as well. Another requirement, more than a requirement, is something that you need to take into account, is that most of the build plugins in Meteor will have a Rspack alternative. With build plugins, I refer to those modules and atmosphere packages that specifically extend the bundler capacities by allowing you to detect and parse files of less, CSS, CoffeeScript, Vue, Svelte, and so on. So if those are used for application code, I recommend you to migrate them to the Rspack alternative. For that, you will need to use Rspack config.js file and apply those loaders and plugins how the Rspack guide tells you to do that. There are some NPM packages holding the behaviors of those build plugins. And other plugins on the Meteor ecosystem, like Southern Types and others that they are not touching application code, don't worry about them. They are going to work. And yeah, basically, there is a possibility that many build plugins could work somehow in your Rspack integration, the Meteor ones. But yeah, again, I strongly recommend migration because then you will get all the benefits on your application code, like HMR, a strategy for your development. Quick reloads on the browser will be the most efficient ones. And also in the future, as you rely on tools that will be maintained. What we have more in the Rspack integration is that we describe custom Rspack config.js files. In these JS files, you can basically host the dynamic configs of your Rspack considering the Meteor environment modes. You can have things like, okay, I want to consider specific plugins in the Rspack or Webpack world to only be applied on the client or the server, production, development, or even the test environment. You can have flexibility on applying those wherever you like to. So what has been the benefits of this Rspack integration? Remember the motivations that we have initially. Of course, the development experience we wanted, and we knew that this was going to improve this part of the Meteor experience. And this has been the data that we have got. In the simple task application, we can see that now the reduction has been on average in all the phases, like 70% of average, 75 or something like that. This is like 4 times faster. But the biggest gain here has been client rebuilds, because now with the new dev server that Rspack is using and the new HEMR, rebuilds now are delegated into Rspack, and we have cut the refresh time 90% or something like that on reduction. This is 9 times faster. What we have also improved is the other motivations that we had. And one of the most requested features, that is tree shaking. Rspack implements tree shaking in the most up-to-date state. So, and other post-compilation processes. So with that, in the simple task application, this is just an example of app, and running the meteor profile command with the signs only, we have seen that the reduction has been about 50% of reduction of the application size. What does it mean? Client bundles are now thinner, meaning less code is shipped, faster reload times for your Meteor clients. So these results might vary by app and the dependencies, because not all the dependencies are traceable in the best way, but for sure, adopting this, you will get gains. Small or even much larger gains. For me, 50% is too much, but can be even more. Then we have also improved the bundle visualizer. For those that already know, we can get a bundle visualizer of the Meteor build with this command. And yeah, this is the Meteor bundler. And the thing that you see in blue is going to depict a little bit the diagram that I was showing before. All this blue area is the packages code, the Meteor core packages and the Meteor third-party packages. And then the purple zone here is the intermediate artifact, in this case, the client application. But then with the Rspack, what we get is a new view just for your client application. And in this view, you can see a tree map where you can see specifically all the NPM packages that you are using, the chunks from your dynamic imports. You can also have fine-grained control over the modules. You can understand and spot opportunities to shrink more the code, and etc. I encourage you, whenever you can test this integration, to run this command. You will get this loaded automatically. But Meteor 3.4 also brings in modern setups. Of course, we have support of React compiler. We have support of the latest version of Vue, Solid, Svelte. I know that, for instance, Svelte, I think we were not supporting Svelte 5 version. Tailwind integration can be also possible. We have provided backwards compatibility for things that are really Meteor specific, like Blaze or even CoffeeScript. And there are much things to explore, like Angular. In the case of Angular, I think it's going to be a little bit more need of exploration, because the way to integrate Angular in the Rspack config is not as easy as the other libraries. And yeah, I'm excited just to see the opportunities to include that as an experiment. And then again, with Meteor create command, when you hit the Meteor 3.4 version, the beta in this case, you can get the examples of the skeletons that you were able already to use. You will get the Rspack, for instance. This is an example of Vue plus Tailwind. And yes, here you have a loader of Vue files, the extensions to be analyzed, and the CSS with post CSS, because this is the requirement for Tailwind. We also have many modern features like dynamic imports. This time we use the standardized way, which is via HTTP. With this, we can load these chunks via HTTP, and even the strategy that we use to catch those HTTP builds in Meteor has been also applied to these chunks recently. Or if you want to customize them and get the benefits of this standard and what you can control over HTTP, you can do that. CDN, service workers for PWA and offline usage and so on. We also have a full ESM support. This was something that was really requested. There are many issues of Meteor users trying to import specific packages on the latest versions that they could not install in the Meteor bundler. Why? Because the Meteor bundler does not support ESM package definition. So this has been a way to unlock that possibility. So you can now use React Router, for instance, in the version 7 and many others. And also an interesting effect here is the secured builds. So this is when you use the if conditionals in Meteor to put Meteor is server, Meteor is client. What happens in Meteor is that you normally use them in shared code. Shared code is that code that will be compiled for the client and for the server. But in the built-in Meteor, you need to take caution because, Meteor is server is not whipped out from the client end. So this has the risky for you to inject secrets in your client bundle. So with Rspack, this is solved. This code that is supposed to be on the server won't be ever hit the client. And there is much more that I encourage everyone to explore and to test. And some advanced customization I'm going to talk a little bit about is, for instance, you can use service workers with a workbox. This is a tool really standardized in the ecosystem in order to describe what your service worker is going to behave. And yeah, it's really convenient in order to not maintain that for you yourself over the time. Also, you can import in your application code different kinds of files like images, fonts, PDFs, Markdown, and doing it also with optimizations pipelines within your build system. You can have some plugins that will minimize those images to have the best and the least weight possible in your production bundle. You can also establish some code patterns for replacement from your source code to the final build. You can also use advanced JavaScript obfuscations tools. You can inject in your build pipeline like TypeScript and Slim checks. You can also use only for productions, for instance, these checks so that you ensure that your application will enforce your quality code tools and those errors that could come due to types. So, and there is much more. Basically, at the end is that whatever is supported in Rspack, Meteor now is going to support it. And when I say Rspack, it's also Webpack because at the end, Rspack is like the successor of Webpack, and Webpack has been a really mature tool over the years with a lot of plugins, with a lot of knowledge there that open up, a pool of many, many other tools. So yes, we need feedback. We need feedback for the Meteor 3.4 version. It's in beta, as I said. We are going through different phases of stability, extensity for making sure that everyone that is trying to adopt this is not running into issues, and those issues are solved either to making from our end more automation or giving you the steps to follow for the migration. And we are also accepting contributions. We have a queue of contributions waiting to hit next versions, and they are going to, of course, hit 3.4. So yeah, we need tests, we need reports, we need shareable reproduction repositories above all, because this is our quick way to be in the loop for delivering new improvements. And yeah, there is also updated documentation on the new modern build stack with all details that has been covered here and beyond that. So yeah, please start testing and let me know about everything. The Meteor forums is also a good place to be to catch up about everything that we are doing in the Meteor 3.4, the phases that we are and everything that we are adopting and doing. And yeah, towards the official version, we will be communicating there everything. So yeah, I think this covers all the Meteor bundle improvements that we have done so far and the most immediate action on it. Thanks for watching, and yeah, I'm open if I have time to any question. Yeah, let me know.
Thank you very much, Nacho. We do have some question first. I think from me is, will eager loading be deprecated in the future? And I'm thinking here for Meteor 4.0 or something like that.
I mean, eager loading of the Meteor application code is something that has been deprecated for really long, because I think the examples of Meteor apps has included the entry points for a really long time. We have not removed that. Maybe it's a good opportunity to remove at some point, because recently I did a survey on the forums, and most of the people, I think 90% or more like that, were using this approach already. So I think it's a good candidate for just remove it. This is different than eager testing discovery, because I know that many people is using the automatically discovering of test files for we run. And we have ensured in Meteor 3.4 that this is kept. So yeah, this will be our plans.
Awesome. Let me scroll down. Would it mean that we don't need Meteor SCSS package anymore and Rspack will take care of it?
Yeah, sure. You can use the Meteor CSS. I think it will work for sure if you just import your SCSS file in your entry folder. The entry folder is the one that has the file of your entry point for the client. If you leave those files there, are going to be watched automatically by the Meteor compiler. You can ignore them and transit to Rspack or whatever. There is details on the docs. But I really recommend to migrate to the counterpart of Rspack, because then the HMR will quickly react in the most quickest way possible into changes.
Okay. Did you consider using Rolldown as the bundler since Rollup, since it's Rollup API compatible?
Yeah. I mean, what happened with roll down, that I think is being imported into Bit, if I'm not mistaken, because Bit is using roll up behind the scenes. The thing is that, yeah, I think so. The thing is that, we tried to experiment with Bit, but we get some troubles on the setup. Also, Bit is having as an experimentation roll down. So roll down is not as mature as Rspack is nowadays. So definitely there is opportunities to include that in the future, but we have tried to stick in something that, we have proof of this being a working approach so far.
Okay, there is a question here from T. Castelli. What do you have planned after 3.4 is released besides ChainStream? Do you see any more improvements that could be applied to the Meteor banding flow? I think that will be answered later on in the keynote, but I'm not sure if you want to put something, just one snippet maybe, from the bundling size.
Yeah, the bundling size, I think this is the proper thing, because with Rspack, we have opened a new space of opportunities. Maybe what we can do to explore in the future is to include many of these setups as presets, not only as skeletons, but as presets. So for that, we can include and have automation done to include smartly service workers for making an offline application, or we can expand to use more SSR strategies that are coming also with Rspack integration or possibilities to embrace those. So yeah, definitely there is an open space. Not sure if they are going to be priorities, but of course, those are possible. And of course, I'm going to encourage everyone to explore those and to share them on the Meteor forums, because at the end, using Rspack is using the Rspack config file. So if you kind of get into a specific setup, you feel comfortable and is providing some gain into your setup, we can share it and we can see if we can include it on the core.
Okay, let me just scroll down here for your, oh, I think that was it. Yes, client bundle optimization. Oh, that's Kuster. And that was, no, and this is you. So here is the link to Roti. Anybody else? Last chance for question, and then it goes to Italo to present his part. Let me also put this, where do we have it, into our notes so that it's ready. So no questions from now on, or what I'll do, I'll end the recording, so if you can ask any private questions.